Brady, the Chief Security Officer, or CSO for Stack Corporation, has to walk a delicate balancing act every day, securing the company's digital real estate, recently expanded into the hybrid multi-cloud domain as part of Stack's digital transformation strategy, while still enabling the agility and flexibility that compelled the move to cloud in the first place. In other words, remaining secure while being able to move quickly. The CSO's team has some work cut out for them, owing greatly to the company's decision earlier to invest into Red Hat OpenShift as the central pillar of their hybrid cloud architecture. The platform boasts industry-leading security capabilities that are built into OpenShift, such as things like Red Hat CoreOS operating systems and SC Linux capabilities for securing the Linux kernel in containerized environments. We'll cover what these are in a few moments. While these capabilities are in many respects enabled out of the box, there's still much to do with Brady's teams to secure their security environment across dynamic areas like you would require for a hybrid cloud computing environment. And these are continuously subject to growth. So a regular cadence of new faces, new requirements, and new team members are continuously coming out of the Chief Innovations Officer's team, Amy, who we met previously in Chapter 1, and the ever-present threat of external forces that might include malicious actors or those looking to intrude into Stack's digital domain. This is a company in the early days of the digital modernization efforts. The unique challenges of securing containerized applications and securing orchestration platforms will put Brady and you to the test. All software, proprietary or secure, has long been the target for cyber hackers, attackers, and would-be bad actors. This is not to suggest that open source is inherently less secure than products that are built in a proprietary manner, not at all. But there is something to the old adage of you get what you pay for. And as we'll explore later, there is a world of difference between building systems for pet projects, personal projects, and so on, versus designing for the needs of enterprise. Kate Compton makes a delightful comparison of free or open source software to the types of curbside donations you might find after a move or when the college dormitory is empty come springtime. In other words, mattress wear. Sure, it's free, but like so many things that you might get for free, you generally end up getting what you pay for. Mattress-sourced software might be the byproduct of an academic project or a developer's Friday night whimsy. You really generally don't know what you're getting until you dig into the project. Making project code open source is a potential way to give new life to the project, but it also comes with the expectation that there's a fair bit of cleaning up to do in terms of cleaning out software bugs or literal bed bugs before you would want to consider putting that mattress or that code into production. The point I want you to remember is that open source software for the enterprise requires much more consideration and effort in order to do properly. You're almost always better partnering with an enterprise open source vendor than you are trying to do it on your own from the open source community itself. Using privileged escalation to escape running pods, moving laterally through a cluster across multiple tenants, man-in-the-middle attacks against public services leading to linked credentials, remote execution of commands executed against exposed APIs with malicious intent. What do all these things have in common? In general, each vulnerability has surfaced within Kubernetes, or K8s, as the underlying Linux kernel that is running those systems that were made vulnerable. The good news is that almost all of those vulnerabilities were discovered by the developer community and received fixes almost immediately after their discovery. The challenge for security teams like Brady's is to spot those holes in advance and to patch them using vulnerability scanners or remediation procedures as part of a well-defined and automated playbook for tackling security threats. So you might be asking yourself, why spend the time discussing these examples of breaches, security vulnerabilities, and so on if they've all been fixed and if only a few of them have really led to real-life data breaches? And I can't emphasize enough that securing workloads from unauthorized access, whether that's internal or external, is absolutely critical. So where should you focus your company's efforts to secure modern enterprise IT estates? Things like cloud, distributed, or hybrid, or something in between. And what do these physical boundaries have in common? Focus on what you can control, primarily your data. This also happens to be your company's most prized asset, and you should control access to that data relentlessly and religiously. It's the one asset that your business cannot survive without and would likely fetch a shocking ransom should someone happen to compromise it or steal it. So let's explore a few areas where you can prioritize on protecting your company's data assets. For orchestrated multi-cloud environments that might be running on Kubernetes, containers will continue to play a much bigger role going forward compared to how they did in the past several years. Having a secure, trusted platform foundation for orchestrating those containers is paramount to building a successful cloud implementation strategy. As containers are really nothing more than a process running on a Linux system, it shares the host kernel with other containerized processes. Each of these processes are isolated from one another using kernel spaces. And I won't go too deep here as we'll cover it later, but the point to be made is that container security is Linux security, which is why things like SE Linux plays such an important role in what we're talking about with the securing of your containerized and orchestrated environments. Red Hat CoreOS, for example, is based on a trusted and mature Linux distribution known as Red Hat Enterprise Linux, or RHEL, and it inherits all of the robust security attributes as a basis for that secure operating system for containerized platform environments. Each process on the Red Hat CoreOS has an associated context and rules defined in terms of interactions permitted by each process. The current cybersecurity market is a crowded space with thousands of software projects and vendors, OSS projects that are offered, and across a plethora of different tools and vendors that you can work with. But many of these technologies still cater to the traditional monolithic style of applications that are typically running on premises, and very few of the new entrants focused on those tools are designing them for hybrid multi-cloud containerized environments. They run the gamut from endpoint management to IAM. Everything that runs on premises has a different set of rules and a different set of tools than what you'll typically be finding on a multi-cloud environment. Many of these tools are often siloed or are very niche, making it a difficult topic for security administrators and analysts to learn or to perform as part of their day jobs. Many gaps exist in the often segregated approach that we've talked about, which can be alarming when you think about how much of industry and business is currently moving towards multi-cloud domains and environments. And for that reason, we're going to spend quite a bit of time on these modules, looking at the tooling that's available out there, particularly in the context of Red Hat OpenShift, and how it differentiates from those previous strategies. Brady's security team is asked on a nearly daily basis to validate and secure the deployment of their applications. And those deployments are often coming out of the Chief Innovation Officer's office, AMI, which you explored in part 1 of this hands-on series. And their agile development models, techniques, and employed strategies ensures that Brady has a constant stream of deliveries and updates and other items that need to be secured by the CSO team. But what it means in terms of a practical hands-on perspective is very different from the theory that we've been talking about. So in the coming module, we're going to take a pause on this theory and look at how we get hands-on with that process of securing a containerized, orchestrated multi-cloud environment.